All right, so we move on to organizing and displaying data. And as we already know now that data could be both qualitative and quantitative, we will learn about organizing and displaying data for both qualitative and quantitative nature. Now, with qualitative data, these are a couple of things where how we organize data by frequency distributions and graphs. Let's have a look at this example here of qualitative data where a professor in a statistics course is trying to do a survey where they ask students what kind of grades they would expect. And in this case, there are 28 students in the class, so that's your sample size of 28. And you see that people have given their expectations about grades, in this case A, B, C, D, and it's not like QUT 1 to 7, different kinds of labels used here. So at this point of time, what you see on the screen is the raw data. So the data is not organized in any way. So when we organize this, it would look like something like this. All right, so here it is. A, B, C, D, E. So now we have organized them in a form where I see how frequently students responded that they would get a certain grade, like A, B, C, D, E. For example, with A, there are 9 students out of 28 who said they're going to get an A. 12 said they're going to get a B, and so on. So this is what a frequency table looks like. Okay, so it is much more informative than just looking at the raw data, particularly when you have a very large sample and have no idea how the responses have stacked up. Even better way of showing this data would be to calculate the relative frequency, which is basically just representing the frequency in a percentage form. For example, 9 out of 28 students would represent about 32.1% of students in the class. Similarly, 12 students responded that they would get a B, which is about 42.9, close to 43%. So that makes it much more informative to your audience when you present number in percentage forms in this case. For example, I can say that 75% of the students in the class said that they would get either an A or a B, okay? And that's a very small percentage thought that they would get an E, and so on. So frequency and relative frequency is very helpful in summarizing qualitative data. And it's often done in Excel using a pivot table, which we'll be doing during the webinars. Another way of representing the same data, the same information you saw in the table, is to organize them in the form of a bar chart. And again, the same information is presented, but this time it's presented in pictures. And you can see that most people expected to get a B followed by A, which is what we saw in the tables. So many of us are visual learners. I remember having a CEO when I was working in an office in New York who had really not much sense for numbers or looking at numbers in table forms, but when you presented him something in a chart, boy, he got very excited. So basically, you know, you need to know your audience, and sometimes you can make things a little bit interesting by putting in charts rather than plain tables. Charts could also come in various forms, and the same information you saw in a bar chart in the previous slide could be organized in a pie charts form, 2D or 3D shapes. Again, these are the fancy stuff people do. Again, this makes your report very interesting if you just mix and match with different kinds of charts rather than using one variety throughout the report. So basically these things are very easily done in Excel and stat tools. Some of these things we'll be practicing during the webinars. Moving on, with quantitative data, you also use frequency tables, which we just saw for qualitative data. In addition, there are things like histograms and line graphs and scatter plots, which are very helpful for summarizing quantitative data. Let's have a look at this particular table where we have organized quantitative data in a frequency form. So let's say we have surveyed age of CEOs in Southeast Queensland, and we can see that there are 25 people we have surveyed here, and we have observed and noted their ages, and then from the raw data we organize them on the right hand side in a frequency table form where we exactly know which age categories contain how many CEOs. And again, these categories, as you can see, is something we have created ourselves. So it was not there in the data itself. For quantitative data, you have to create these categories yourself. In this case, we have created 5 categories: under 35, 35, and 36 to 45, under 55, under 65, and then under 75. How many categories you create is something of a choice you have. You organize the same data again in a pictorial form. It's called a histogram. Okay, so the same category is now represented in a graph, and this is similar to a bar chart we saw previously, but the only thing is there is no gap between the bars here. You can see because we have chosen categories which are exactly adjacent to each other, so the histogram does not contain any gaps in it. And again, visually it's really appealing, and you see most of the CEOs would be lying in this category of under 55, which means 46 to 55 years. So most of them are in that age category. Right, so again, revisiting the question that how many categories we are going to create. It's a choice for every person has, but the choice should be made judiciously. For example, if you have only very few observations, less than 50 observations, it's not usual for people to choose more than 5 to 7 classes. If you choose too many classes, or if you create too many categories, then obviously the problem is you may not have enough data or enough observation for each of the category to draw any meaningful conclusion out of that. So this is just a rule of thumb presented here. The choice is yours, and you have to play around a bit to see which actually works best for you. Line graphs, again, is not something you'd be frequently using, but in some cases it'd be helpful, particularly with time series data. You can see in this case, data is presented for a company's sales, quarterly sales from 1993 to 1997, and the total numbers are presented on the right-hand column. Now, if you look at this data, you may not be able to understand what's going on unless you put it in the form of a line graph. And this is what the line graph tells you here, is between 1993 and 1997, sales have definitely grown over time. And you can see there is some kind of exponential growth at times. And the other interesting pattern you can observe here, that there is some kind of seasonality in the sales. That means sales spike during one quarter, and then after that there is a decline. So that's not unusual for industries like retail, where you have a lot of sales leading up to the Christmas, and then there is a lull in the March quarter when sales will dip. So you can easily see that happening here when you put the data in the form of a graph. All right, the next one is scatter plot. Now this is really important for us, and you'll be using it a lot. I can promise you that. It's good for both time series and cross-sectional data. I would say, it's very, very useful for examining relationships between two variables. So as you will shortly see. But it's also sometimes used with one variable, like something like production control, as the next example will tell you. So in this case, in this example, we have created a scatter plot. What we have done is we have monitored the weights of tomato can fields over the course of a day. So the workers come during the morning, start their shift around 7:30, and they work till 5. and they fill up cans of tomato. I know these processes have been more or less automated now, but this example is probably from a bygone era when things were done manually. And you can see that if we observe the weights of the can fills from the morning to 5 o'clock in the afternoon, what's happening here is you can see the scatter plot tells you a story. The cans sometimes are overfilled or sometimes underfilled, which is probably something we would expect. They will not be exactly 400 grams. But you can see that this is the average fill. The red line indicates the average fill of the cans. During the morning, you'll see that when they start work, it's pretty randomly scattered around that middle red line. So that means some cans are underfilled and overfilled, but that happens quite on a random basis. As you progress towards the end of the day, you suddenly notice a change. You can see that you have more underfills, than overfills at all as the day progresses. So possibly people are trying to do their job faster and then go home, and you see a lot of tendency to fill in more cans. And there's a clear trend here between 3 and 5 when cans are underfilled. So that is something very useful for somebody trying to control a production process. With bivariate data, when we deal with not just one variable but two variables at a time, again we can have qualitative bivariate and quantitative bivariate data. Look at this example of CEOs. We have their qualifications, the 25 CEOs we have surveyed. Again, we have their gender this time, we have age of the CEOs, and also their annual salaries, which is slightly on the lower side, but possibly the data was collected many years back. And when we look at this data set and particularly zoom in on specific variables, for example, in this case, we are focusing on gender and qualification. So both of these are qualitative variables, and that's why we call them qualitative bivariate data, how one varies with the other. In other words, is there a relationship between gender and qualification of CEOs? So to know this, again, we have to organize the data. And since it is a qualitative data, the best way to organize them, again, is to form a frequency table. But in this case, the frequency table has both rows and columns because we are dealing with two variables here, gender and educational qualification. Now again, when you fill in these boxes, put these numbers here, you can see the story. With the female CEOs, they have only there's two types of qualification, either they're bachelor's or a master's, whereas there is a wide variation among the male CEOs where you notice a few PhDs, but there are a couple of people who have not even a bachelor's degree, so there's a huge dispersion in their qualifications. So it's much more informative to your audience to know this kind of information. You can scheme from the data. And you obviously get separate counts of male and female CEOs. So out of your sample of 25, you have 18 males and 7 female CEOs. And you also have separate counts for different educational qualifications. So these kind of things are easily done in Excel using a pivot table, which we will be practicing during the webinar. Okay, same information, again, presented using bar charts or stacked bar charts. Go for the one you think best present your case or the point you're making. Moving on to quantitative bivariate data, we have picked up two quantitative variables, age and annual salaries. Both are numbers. Again, the question here being, do annual salaries and age are related? Okay, that's the point in examining bivariate data, whether one changes with the other. Now in this case, because it's a quantitative bivariate data set, so what we do is we use a scatter plot, which is the best way to show relationship between two quantitative variables. And you can see again the scatter plots here tell you a story. Barring one particular person here in the data set, for all others it seems that age really didn't matter in terms of determining their salary, or it is not related to their salary at all. So most of the CEOs are earning around this $100,000 mark. But there is one person who has almost 5 times the salary of the rest. So you can think this person must be having some kind of special skills or something. So that person may not belong to the data set in that sense. So if we are asked to draw a conclusion, it will be fair to say that age has very little to do with salary, okay? And we may not consider one particular data point, and because it seems that it's quite far off from the rest. And in statistical terms, it's called an outlier in your observation. And sometimes we come across a couple of outliers in our data set, which may, influence our conclusion at times. And if we remove the outlier from the data set, then obviously the picture suddenly changes. So how we deal with outliers or how we treat them is something we'll consider in the later classes. But suffice it to say at this point that a scatter plot is very helpful for us to catch these outliers. Okay, so if somebody is far off from the rest of the data set, you can easily identify that person on the scatter plot. More example of a scatter plot, because you'll be using it so frequently. A personal manager suspects that absenteeism and age of workers may be related. So that's his or her belief. So they're trying to test it with a survey of workers. So just take a random survey of 10 workers and you get the results, which are on these 2 columns here. We have put their age and days they were absent from office in the 2 columns. Again, because both of them are quantitative variables, we use a scatter plot and try to answer this question whether age is related to absenteeism. And again, the scatter plots obviously tells you a story here, that you can see that as age of workers go up, the number of days they were absent from work actually declines. So there may be some merit in that argument of that personal manager or the belief. You may say that possibly there are other factors that could affect number of days people are away from work than age, and how do we actually know that those factors were not in play here in this case? Well, we cannot be answering that question definitively here. So we cannot really draw a definitive conclusion unless we control for all other factors that would have affected the days they were away from work. But at a very superficial level, we can still see that there is a relationship between age and number of days they were away from work. Okay, so it may be worth exploring that whether other factors did influence this result. So that's basically, in summary, the ways we present qualitative and quantitative variables in terms of tables and graphs, and we'll have more practice of them, I hope, in the next classes. Thank you.